Hello, today we're going to look at compound probability. And when we've talked about probability, we're talking about the likelihood of something happening. And so compound probability is when we are going to have more than one thing happen. So we're going to have multiple events, and we're going to figure out the probability of multiple things happening. For an example, let's think about if we were to flip a coin 3 times. So 3 coin flips. And what if I wanted to get heads every time? So I want 3 heads. And I want to know what my chances of getting 3 heads in a row would be. So when we're solving this problem, we need to think about the chances of getting a heads if I flip a coin. So if I flip a coin 1 time, my chance of getting heads is 1 out of 2. And when I flip a coin again, my chance is going to be 1 out of 2 again. And then the next time it will be 1 out of 2 again. And we're going to multiply these fractions together because when we solve compound probability, we multiply the probability of each thing happening. So I multiply fractions, so I'm going to multiply the top times the top and the bottom times the bottom. Okay, so 1 times 1 times 1 is going to give me 1. Okay, 2 times 2 times 2, well, that's going to give me 4 times 2, which is 8. So my probability would be 1 out of 8 if I wanted to get 3 heads in a row. So I have a 1 in 8 chance. And then we could convert that to a decimal or percentage if the question was asking for that. So let's take a look at another example. Okay. Let's say we want to get heads on a coin. And then we want to roll a 5 on a die. Okay. So if I had a coin, I flip it, I get heads, then I want to roll a 5 on a die. Okay. So we know the chance of getting heads on a coin is 1 out of 2. And we're going to multiply that by the chance of rolling a 5 on a normal die. And so a normal die has 6 numbers, so it'll be over 6. And there's only 1 5, so it'll be 1 over 6. And we multiply, top times top, 1 times 1 is 1. Let's make that look a little better. 1. And then 2 times 6 would be 12. So I'd have 1/12. Okay. We'll do one more example using cards because they like to ask questions using a standard deck of cards. And so let's say I want to know the chance of drawing a jack and then a king. And we're going to say with replacement. So what that means is I'm going to put the card back in. So if I have with replacement, I put the card back in after I draw it. And if it says without replacement, that means that you keep it out. And so your denominator will change when you draw your card. It would go down 1 each time. Since it's being replaced, we're putting the card back in. So there's still going to be the same number of cards. And there are 52 cards in a deck of cards. And these questions will tell you that when it asks about a deck of cards. It'll tell you there are 52 cards. And so we need to know something about a deck of cards. Okay, there are 4 suits, and there's 1 number for each suit. So that means that there are going to be 4 different jacks. You're going to have a jack of hearts, diamonds, clubs, and spades. So that is 4 over 52. And then we are going to multiply that by the chance of drawing a king, which would be 4 over 52. Now, 52 is a pretty large number to multiply with, so we might see if we could reduce. So 4 actually will go into 52. And so we could change this, and I'm going to change the color so that you can see it. 4 would go into 52 13 times. So it ends up being 1 over 13, and then since this is the same fraction, it'll be 1 over 13 as well. So we can go ahead and reduce it before we multiply. Makes it a little easier to reduce. And so now I've got 1 times 1, which is 1, and then 13 times 13, which is 169. So my chance of drawing a jack and then a king, if I put the card back in, is 1 in 169. Okay, so hopefully this will help with the compound probability. All that we are doing is just multiplying all of the probabilities together. And one thing we have to be careful of, if it's with replacement, that means that we put it back in. And if it's without replacement, that means that we keep it out after we draw it. So hopefully this helps.